Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this video, we're going to be talking about dilution and how to actually calculate it. Let's get started. So in the previous video, we learned how to calculate the concentration of a solution, and that's really important when we want to determine the exact amount of quantity of solute that's present in the solution. And we can use that and manipulate that formula to be able to solve for the mass or the volume of the solution, so forth. Now, this idea of dilution is needed when it comes to actually working in the laboratory. And so oftentimes when people are preparing solutions, they create what's called a stock solution. So a stock solution is simply a very concentrated solution, meaning you put a lot more of that solute in that solution environment. And so then whenever you're ready to use your solution, you want to bring it down to a more feasible working range or make it more dilute. And so we do this by simply taking and adding a bit more solvent to make the environment in which the moles that are present larger, thus creating a diluted solution. And so remember, when you're doing those molarity calculations, the amount of moles is remaining present. And because of this, because the moles in the original solution and the moles in the final solution are not changing, just the volume that they're in, we can then take and exploit this to come up with a dilution formula, which is known as M1V1 equals M2V2. And so this is basically saying, since I'm not creating or adding any more of my solute, I'm just simply changing the volume, the amount of moles on both sides of the equation are equivalent. And so your M1 and V1 represent your original conditions, and your M2 and V2 represent your diluted conditions. General rule of thumb, you're going to expect that your M1 should be greater than your M2 because that represents your original compared to your diluted. So you expect that number should be greater. And your V1 would be less than your V2 because, again, we're changing the amount of solvent that's there and thus creating a larger volume of solution. And that's a good thing just to remember. So when you're looking at a problem, it helps you to distinguish what numbers go where. And so if we try this example, it says, to what volume should you dilute 0.20 liters of 15 molar NaOH to make 3 molar NaOH? And so a lot of stuff going on here, but it says to what volume, so we know we're solving for one of our B's, should you dilute 0.20 liters of 15.0 molar sodium hydroxide to make 3.0. And so I always like to actually label and identify what it is that I know what I'm solving for. That way I know where to plug things into my equation. And so if we look at the information that's provided, well, these would represent our original conditions, the more concentrated conditions, whereas the 3.0 would represent my diluted condition. And so therefore the volume that I'm solving for would be the diluted volume. And so if we take our equation, M1V1 equals M2V2, we now know we're solving for V2. If we rearrange that equation, V2 equals M1 times V1 divided by M2, okay? And then we plug it in. M1 is 15.0 molar. V1 is 0.20 liters, and M2 is 3.0 molar. Again, in this case, I'm expecting that my V2 should come out much larger than my V1 because essentially I've taken some small amount of my V1, my concentrated, and now I'm diluting it to a much larger volume. And so if we take that 15 times 0.2 divided by 3, that gives us 1.00 liters is what we would need to make this solution, okay? It says, what is the concentration of a solution prepared by diluting 45.0 milliliters of 8.25 molar HNO3 to 135 milliliters? Now, one question people always ask is, do I need to go ahead and convert the number of milliliters to liters? And for M1V1 or dilution problems, you don't have to. As long as they match on both sides, it doesn't matter which unit you have it in. You just want to make sure that you remember for the molarity formula, your moles divided by volume, you always put liters there. So if it helps you to convert these here, great, but you don't have to. So it says, what is the concentration of a solution prepared? So that means we're solving for M2 by diluting 45.0 milliliters V1 of 8.25 M1 nitric acid to 135 milliliters. So that would be our B2. So again, if we start with our M1B1 formula, we set it to solve for M2. So we're going to divide both sides by V2. So M1B1 divided by V2. And again, since we know we're diluting this, you should already be anticipating that this number, whatever we solve for, should come up less than the 8.25 molar. So M2, we would have our numbers 8.25 times the V1 of 45.0 milliliters divided by V2, which is 135 milliliters. So 8.25 times 45 divided by 135, and that gets us 2.75 as the new concentration when we dilute this substance. Okay, all right, and then this last problem says, how would you prepare 200 milliliters of 0.25 molar NaCl solution from a 2.0 molar solution? So how would you prepare? All right, so if we look at this, 200 milliliters represents our V2, the 0.25 molar represents your M2 from, so that means this was the original, so M1. So what we're solving for, we need to know what V1 is. So again, start with your equation, M1 V1 equals M2 V2. And now we're solving for V1. So V1 equals M2 V2 divided by M1. Plug in. Our M2 is 0.25 molar. Our V2 is 200 milliliters. Again, you do not have to convert here. It's not necessary. Divided by your M1, which is 2.0 molar. Now, if we plug that in, 0.25 times 200 divided by 2, that's going to get us 25.0 milliliters. And so what that physically means is that I would have to get 25.0 milliliters of that concentrated 2.0 molar solution. And then I'm going to add enough water to get up to 200 milliliters to create a total solution volume of 200. Notice I didn't say add 200 milliliters to the 25. We're just going to add enough water to get up to that 200 milliliters. I hope this information helped you understand how to do dilution-based calculations. Be sure to like, comment, and subscribe, and let me know what other content you want to see. I'll see you guys in some future videos. Have a great day. Talk to you later. Bye-bye.